we've moved to item 3 out of the 100 items we have to handle. And in this item, we have the scenario states that a certain state in Uganda is investigating a new smart traffic management system designed to optimize traffic flow and reduce congestion, especially during the rush hours. The system caters for road density, vehicle capacity, and pedestrian movement. The engineers have developed some indicator related to the efficiency of the traffic flow on the major roads. The indicator is theta, which relates to a specific traffic cycle parameter, which is considered when the following equation is satisfied. And the equation is 4 plus tan squared theta is equal to sec theta 7 minus sec theta. The system needs to be designed in a way such that an optimal traffic flow is achieved. Then the task help to determine the indicator values. So this statement says values, not value, at which the system may be efficient. It means that we are going to end up with two or more values. So how are we going to deal with this number? First, we summarize our question. So we are given 4 plus tan squared theta is equal to sec theta 7 minus sec theta. In these numbers that we're trying to solve, don't fight to master the number. Try to understand the logic behind the number and how that number is solved, such that when it comes in either UNEB or more, it's not going to come directly as this one that we are dealing with. They are going to twist, but the logic remains the same. For this number, the question requires us to find the value of theta from this trig function. We are given a trig function and we're told to find the value of theta. And take note of this s. We are given the values. Those are the values we have to find in this number. So after understanding that the question is coming from trigonometry and what they want is theta, then we can move on to dealing with trig functions. When you're dealing with trig functions, try to look for identities that are going to help you overcome the number. For example, I'm seeing tan and sec theta have a relationship. You know very well that when I say from our mother equation, which is sine squared theta plus cos squared theta, these are equal to 1. We all know that. So if I want to get tan, I divide by cos. So when you divide by cos, you remain with tan squared theta plus 1 is equal to 1 out of cos is sec squared theta, like that. So this is the identity. If I want to make tan squared theta the subject, I move this one that side. We remain with sec squared theta minus 1. So are you saying that sec and tan have a relationship? So I'm going to try to turn this tan squared theta into sec by replacing it with that. So it's going to be 4. It's going to be 4 plus what's tan? Tan is sec squared minus 1. Sec squared theta minus 1 equal to sec theta. So I'm going to be opening this bracket at the same time dealing with the left. So when I enter sec theta, it's going to be 7 sec theta minus sec squared theta. So when I get to this, my mind tells me or your mind should always be telling you to form a quadratic equation. So you have to be forming a quadratic equation there. So it's what I'm trying to formulate. So from this, having 4 minus 1 gives us 3 plus sec squared theta equal to 7 sec theta minus sec squared theta. Oh. So if I move this sec squared theta this side, it becomes 2. It becomes 2 sec. Then I'm going to move this that side such that I end up with 2 sec squared theta minus 7 sec theta plus 3 is now equal to 0. Why is 0? Because on the right hand side we've removed everything. There is nothing there. So after forming this, I'm going to say let any unknown, maybe x, let x be equivalent to sec theta, like that. So when I insert in x, it's going to be 2x squared minus 7x plus 3 is equal to 0. Then from our bulldozer, we know that x is always equal to negative b. So the formula is x is equal to negative b plus or minus root of b squared minus 4ac divided by 2a. It's the formula I'm going to use here. But now my b is already negative. So when I put in negative b here, it's going to become positive. So 7 plus or minus root of negative 7 squared minus 4. My a is 2 and my c is 3. Divided by 2. What's our a? 2. So there, after showing this formula, you can use your calculator and get the values, whereby x1 will be 3 and x2 is going to be 0.5. But remember, we are not looking for x, we are looking for theta, and x is equal to sec theta. So I'm going to say my first x is 3, x is equal to sec theta. But we know very well that sec theta is 1 out of cos theta. So it's going to be my x, which is a 3, is equal to 1 out of cos theta. It means that 1 out of 3, the reciprocal of this is equal to the reciprocal of the right hand side. So it's going to be 1 out of 3 equal to cos theta. After getting that, I can take the inverse, remain with 3, cos inverse of 1 out of 3, giving me, it's going to give us 70.53 degrees. But we very well know that when you try to sketch how these angles are going to be behaving, all students take chemistry. This 70 lies within this region. Then we have to look for another angle that satisfies this cos. Cos is positive within that region, which is going to be 360 minus theta. So it's what we're going to do. We're going to say 360 minus 70.53 is our next angle there. So the first angle is going to be 70. The next angle is going to be 289.47 degrees, like that. We have two values of theta. So the next value is going to be x is equal to 0.5, but x is sec theta equal to 0.5. Then we know very well that this is 1 out of cos theta equal to 0.5. When I take the reciprocal, cos theta is going to be 2. And this one is a math error. Why? Because the only accepted maximum of cos and sine is 1. We can't go beyond this. We can't go beyond 1. When you take the inverse of 2 is a math error. So this root is not applicable. We shall only settle. This one is not applicable. We shall only settle with these two as our values that are needed. So those are the two values that are needed in our item 3. So our next item is going to be item 4.